Hello and welcome students. My name is Shampa. Today we will understand some basic figures, some basic quadrilaterals in geometry, namely parallelogram, rhombus, rectangle, square, trapezium and kite. So let's begin. Now the question is, what is a parallelogram? Now this is a parallelogram. Let's name it ABCD. A parallelogram is a quadrilateral and its opposite sides are parallel and equal as well. That is, AB is parallel to DC and AB is equal to DC. Similarly, AD is parallel to BC and AD is equal to BC. Also, they have a special property. Now let's draw the diagonals of this parallelogram. The property is the diagonals of a parallelogram bisect each other. That is, say AC equal to 7 centimeters and BD equal to 4 centimeters. And let's say they intersect each other at point O. Therefore, AO is going to be half of AC, that is 3.5 centimeters. Similarly, OC will also be 3.5, and in the same way, OB is equal to 2 centimeters and OD will also be 2 centimeters. So, the diagonals of a parallelogram bisect each other. Now the question is, what is a rhombus? Now this is a rough sketch of a rhombus. The only difference between a rhombus and a parallelogram is, in case of parallelograms, opposite sides are equal. This side is equal to this side and this side is equal to this side. AB is equal to DC and BC is equal to AD. That is the case in case of parallelograms. In case of rhombus, the adjacent sides are also equal. So, in case of rhombus, AB is equal to AD and AB is equal to DC as well, which clearly indicates that all the sides of a rhombus are equal. Other than that, rhombuses have a unique property. We know the diagonals of a parallelogram bisect each other. We just studied them. The diagonals of a parallelogram bisect each other. The same property holds true for rhombus as well. But it has one more property. The diagonals of a rhombus not only bisect each other, they bisect each other at right angles. This is a special property that holds true for rhombuses. And because square is a special case of a rhombus, it holds true for square as well. We will study about them shortly. Now the question is, what is a rectangle? Here we have a rectangle, ABCD. This rectangle is a special case of a parallelogram where all the angles are 90 degree. Opposite sides are equal and parallel. This is a rectangle. And the diagonals of the rectangle obey the property that they bisect each other. However, because this is a rectangle, the diagonals of a rectangle need not make an angle of 90 degree with each other, but this holds true in case of squares. Let's understand what is a square. Now this rough sketch is a square. Let's label it ABCD. This is a special case of a rhombus. Why? Because all the sides are equal. And not just that, why do we call it a special case? Because all the angles are 90 degree. And there is one more property. The property that holds true for rhombus holds true for square as well. AC is one diagonal and BD is another. This is a rough sketch, but the diagonals bisect each other at right angles. So, in case of rectangles and in case of squares, all vertices make an angle of 90 degree in case of rectangle and in case of square. Now, let's understand what is a kite. Kite is a special quadrilateral, and in this quadrilateral, the adjacent sides are equal. That is, the adjacent side of AB is AD. But remember one thing, only one pair of adjacent sides are equal. This does not mean that AB is going to be equal to AC. No, it is not the case. AB is one side and it will be equal to only one pair, only one side that is adjacent to it. AB is adjacent to AD as well as BC, but it is not going to be equal to BC. AB will be equal to AD and the side BC is going to be equal to CD. So, one pair of adjacent side will be equal and one pair of opposite side, two pair of opposite sides will be unequal. That is, AD will not be equal to BC and AB will not be equal to DC. That's called a kite. Now let's understand what is a trapezium. A trapezium is a quadrilateral where there is only one pair of parallel sides. This symbol represents that AB is parallel to DC and one pair of non-parallel sides. If we extend BC and AD, they will meet at some point, but if you extend DC and AB, you will keep on extending and they will not meet. So AB is parallel to DC. So it has only one pair of parallel sides, that is AB and DC. And I've made one more figure. This is a special case when the non-parallel sides are equal to each other. This is called an isosceles trapezium. So that's it for today, and with some more geometrical figures and their properties.